So let's talk about this question. Construct binary tree from preorder and inorder traversal. So the question given is given two integer array preorder and inorder, where preorder is the preorder traversal of the binary tree and inorder is the inorder traversal of the binary same tree. So construct and return the binary tree. Okay. So the question is saying, the question is giving is there are two arrays. Okay. The first array indicates the preorder, the second array indicates the inorder. Okay. So we have to build a tree, build a binary tree from these two orders. So how can we do that? Let's look how to solve this question. So first of all, we need to understand what is preorder and inorder. Okay. So suppose there is a tree 1, 2, 3. Let's give that number. So in preorder array, you can see my lecture video on preorder, all the traversal video. So you can easily understood what is preorder and inorder. Okay. So in preorder, basically we took the first thing which will come into uh, our loop, which is root, after that left, and after that right. Okay, simple. So in order array, the first thing will come is our left, then root, then right side. Okay. So how can we use this traversal for making our binary tree? So let's take an example. Let's take example of the question. So the preorder is given as preorder and inorder. Okay. So the preorder is given as 3, 9, 20, 15, 7. Okay. 3, 9, 15, 27. 3, 9, 20, 57. Let me correct it. 3, 9, 20, 15, 7. Okay. So in order, what is it? 9, 3, 15, 9, 3, 15, and 27. 20 and 7. Okay. So first of all, in binary tree, we have to find what is important. We have to find the head of the tree. Okay. So if we find head, we can easily construct left side and right side of that binary tree. So how can we find our head? What is our head? So as we can see here, in preorder, the first thing will come is our root node. Okay. So this preorder, in this preorder we can see the first index, which is 0. Let's do indexing here first. 0, 1, 2, 3, and 4. Okay. So the 0 index element is basically our, in preorder, basically our root, we can say. So this is our root. This is our root node. Okay. So how can we basically see, or what is the reason behind this? So we can see, suppose let's make a node, let's make a binary tree 1, 2, 3. Let's make another binary tree, let's call it 4, 9, 20. Let's something called 8, 10, 9, 15. Okay, this is our binary tree. So if we write the preorder of this tree, it's gonna look like this: 1, 2, 3. Okay. And in this part, if we write the preorder of this tree, it's look like 4, 9, 8, 15, then 10, then 20. So as we can see, if we have to find the root, so it will always present at the 0 index of the tree. Same here, if we find root of this tree, this which is 1, we can find that which is always present at the 0th index of the preorder array. So from here we can see that. Let me erase this. Okay, so let's again draw. So after that, we find, after finding the root, the second step will be, we have to find what is the left part of the tree and what is the right part of the tree. So for that, we comes into the in-order array. So for in-order array, we have to find our root node, current root node, which we are traversing. Suppose this is, let's denote our root node, current root node, which is CR. Okay, so we have to find our current root node. So let's see, this is our current root node pointing towards first index of the in-order array. So the left part of this and the right part of this is the left subtree and right subtree. So we can basically write all the elements. This is the part of left subtree, and all these elements present on the right side of the array. Basically, it is right side, and this is left side. Okay, so right side of the array will be 27. Okay, so now how can we find what is the root? Suppose there are, here it is one element present. Suppose there are multiple elements present, 21, 26. Okay, so how can we find what is the root of this left subtree? Okay, so now we can comes to in order array. Basically, in order array try to solve our current root. What is our current root? Okay, so now we will move to pointer here, current root. So it will be, it will give me the current root of that subtree. Okay, so here it is 9, so we can, currently here it is only one element, so we also know that root node of the left child of the root node, which is 3, will be 9. So now we have to find, first of all, this is not an pointer. Okay, so now we have to find what is the left child and what is the right child of the 9. So now again we come to an order array. So as we can see, in order array which help us to find what is the left and what is the right part of right side of right and left subtree. Okay, simple. So again we will find where our root value, current root value present. So here it is present here. So now we can see there is no left side, but there is a right side. But in right side, the root of that 9 is also present, which is 3. So there is no current element which will comes into the right side of the tree. So from here we will get there is no left and right child of our current root node. Okay, so here it is 9. Okay, so there are no left and right child of the current root node. Again we will point to our next point. So now we will come to right side. Now how we will find what is our root from these three nodes which are present in our array. So again we will check our preorder, which will give us the root of the right subtree. So again we will put 20 here. So this is our current root node. Now again we will do the same procedure. Now we have to find what is the left part and what is the right part. So again we will find out where the uh, current root value present. So here it is present, so on the left side and on the right side. Okay, basically I have done the reverse. So this is our left side and this is our right side. Okay, right side and left side. So the element present on the right side will come to the right array 7, and the left element, which is here, 15. Okay, so now we have to find what is the root. Suppose since here it is only one node present on the arrays, so we will put it as it is 15. If there are multiple root, again we come to our pre-order array. Again we will make our current root this node 15, so we will put 15. Again we move, again we will check where 15 is present. Again we will put left and right. same procedure and same procedure with last node. So let's see how to code it. So first thing which we gonna do is we will we does not make every time if we are traversing left and right side. So basically we don't make arrays every time to store left and right subtree. Okay, for that we are taking help of pointers. Okay, so how this will gonna look like, suppose taking in an example, suppose we have in order in order we have given a order like let me rub this. Yeah, so the in order will be 3, 15, 20 and 7. Suppose we have to construct the right subtree of our root node, so we pass our pointer from 15 to 7. So this is our right subtree. Okay, and so this is our right subtree. We are basically passing the pointer, not making an array and again pass it to the recursive call. So it's simple. Okay, again we will do for the same rest of the process. So let's see how to code it. So let's talk about code, how to code this. So first of all we have to make pointers. So let's make it integer type, uh, restart, which is initialized with 0, and pre end. Okay, so pre end will be initialized with pre-order size -1. Same with in order, which is initialized with just a minute, in start, which is initialized with 0, and it's in and which is initialized with in order dot size -1. For 0 based indexing, basically for this is 0 based indexing. Okay, after making all the pointers, first of all we have to find the element in order array in less time, basically. So how can we do that? So we can basically make a map, hash map. Okay, hash table which will contain the element along with its index in the pre-order array. So for that we have to make a map. So let's make it integer 1, integer. It will let name as mp map. Let's run a for loop. For I is equal to in start till where we have to go, till equal to in order in and. Okay, in and. Let increment the I variable. After making mp, we have to take our pre-order, not pre-order, in order and basically our key is here. Our key is basically element yearly, which is present in an order array, and value is the index. Okay, simple. So this is our map part. Map will help me to find that element in big of 1. Okay, so let's try to code. Now we have to make a function which return root of the tree. So in this function let's create tree. Okay, let it be capital. Create tree in which we have to pass our pre-order array, pre-order array along with pre-order, the pointers pre-start and pre-end along with in order array and its pointer in start in end and our map finally. So let's create a function 5 bit, so it should return root of the tree, so we will make return time should be node, return type should be node, in which we have to create here create tree, and for that tree we will take input about, let's do some copy paste because it takes lot of time, pre-order array and along with in order array. Okay, I have done something wrong. Let's and pre-order array along with its int pre-start. Sorry for that. Pre-start and then int uh, pre-end. This is all about in order. Let's talk about in uh, in order in start basically and end, what we can say in and e and okay. So I think in and is pass, in and is pass. Okay, so after in and we have to pass our map. So basically map is our integer type, so let's make integer key, integer value, mp map. So this is our map in which we have to return root. Okay, so how can we do that? First of all, in creating tree, the base condition come first. So what is our base condition? So base condition is basically, if we can say our start pre-start strt pre-start is greater than pre-end, or n start is greater than n end. Okay, so you can relate it with the binary search problem, in which if our start is greater than end, then we will return nothing. Okay, so here we have to return null. After that we have to find after that we have to create a tree node. Let's create a tree node star, which let's name as root, and new uh, tree node, what we can say, what is the value of the first thing. Yeah, so this is our tree node now. Yeah, so what is our root value? It is the first value in the pre-order array. Okay, so what is pre-order and what is the starting value? In start, not in start, pre-start strt. Okay, so this is our root is created. After root created, we have to take care of the element which is basically currently pointing at the root node. So let's take int element which is basically care of current, uh, what we can say, current value in our in order array, in order, and here we have to pass, what we have to pass, root value. So let's keep it simple. root value. Okay, it's basically same thing. We have to find the element which are present at that value, so we can also pass our root value. After that, we have to take something like our basically we can say the distance between them. So let's take called as an element, ELE. Okay, which will be equal to element minus our n start. So what this thing gonna do here? So let's see. So this thing will reflect me basically left side of the element. Suppose our root node is this 3. So in order 3 is our index of that element. So our currently element will be pointing to 1. Okay, not 0, 1. Now in order array, basically in order start an element will be pointing to element which is pointing minus in start value. So it will give me a point of along the left side of that part. Okay, so till left 0 we have to consider as a left subtree of this our root node. So it's simple, nothing much. So let's see again problem. So after creating left side of the tree, we have to take care of basically now we have to traverse the root left side and root right side. So how can we traverse? So first of all, root, here comes our first thing, here comes our root left part, which will gonna say that we have to create a tree. Okay, so now we have to take care, we have to take care little bit here. So for that basically we have to take we have to pass preorder array as it is, preorder array as it is. Now the pre-start value, what will be the pre-start value? Pre-start value will be the basically pre-start plus 1. Okay, after pre-start we will put pre-end. What is our pre-end value? Pre-end value will be the pre-start uh, pre pre-start plus an element. Okay, an element, an element. Okay, after that in order array it is passed as it is. And in start value, what is our in start value? In start value will be our same. So in start in start, and in end value, what is our in end value for the left side? So it will be the left part. So element minus 1, element minus 1. Okay, and mp, our map. Same thing goes with the right side of the tree. Create tree, create create tree, preorder as it is, preorder we can pass as it is. Now what will be the pre-start of? Pre-start will be the pre-start plus an element which will basically takes left and right, uh, basically what we can say the number of elements which are present right side, left side of the tree. Okay, so now we will pass it plus 1. Okay, because if we pass this will um, take over root node also. Okay, so increasing 1. Now pre-end will be the same. Okay, pre-end will be the same, pre-end. Here we are taking, let me preend. Here we have to take, yep, it is right. Okay, so after preend, in order will be the pass as it is. After that, in order, in start value will be element plus one. Okay, element plus one till in end. In and again we pass our map here. So this is the pretty much function about how to make a binary tree from pre-order and in-order travel. So let's try to run this code. I think, yeah, okay, it's size spelling error. So let's spelling error again. And as there are too many variables, we have to take care of the spelling also. So it is running. Let's take example test case, whether it will pass all the tests or not. Yep, it is passed. Let's try to submit this. No, it's giving me TLE. Why it is? Let's. It's giving me TLE. Whether I have matched up in indexing or the root node. If our pre node is equal to pre start will be greater than pre end, in start will be greater than in end. It is right, I think. In start, in end, pre start, pre end. Yep, it is right. We have matched up in our indexing. So let's see if we have to construct tree, the pre-order will be the same. Okay, starting pointer on the left side, basically the root of the left side will be the next element which is present in the array, so it will be also correct. Now pre-end, what is the pre-end? The range, okay, the range will be pre-start plus an element, which is also correct. Basically in order, in start we can say in start is same, element minus one is also same, and p is also same. The right side will be the pre-order, pre-start plus an element plus one, pre-start plus, yep, it is also correct. Pre-end, pre-end is also correct. In order is also correct. Element, so here we are missing one thing. In our root condition, we are returning here, time limit exceed. So, hmm, it's our an element which is element in start, it is also right. Our root index setting, pre-order, pre-start, yep, it is also right. Where we are gonna missing this, let's try to debug. First of all, our base condition, which is pre-start, if it is greater than its end, it will return. In start also, it will return. Okay, I think we are little bit messed up in it. Will be take size of an integer map. Yep, root left, this will be the left subtree, this will be the right subtree of that root node. Yeah, it is also correct. So what is the main cause? Yep, so basically here we have to pass our map function with address. Okay, so let's try to submit it again. And the codes all remain same. Basically we have to pass our map function by address. Okay, so it does not make an more copies of that map function. Okay, so thank you.